This video will introduce convenient functions that make Mitsubishi Electric FA equipment products easier to use. With just a few moments, we'll learn the techniques to generate fixed cycle signals. Do you want to use fixed cycle signal to evaluate programs or equipment? But even if fixed cycle signals were generated with programs, it's still bothersome to adjust the cycles, and it's not certain whether the generated signals are actually correct. System clocks of special relays and timer relays can be useful in such cases. Let's see how it works, together with how to use GX LogViewer to display the generated fixed cycle signals in waveform and how to check the cycle. First, let's see how to use system clocks. System clock is a function that automatically generates a power signal that repeatedly switches between on and off, so it's possible for the users to specify the on and off time of special relays SM414 and SM415. The on and off time are specified by storing values in special registers SD414 and SD415. Let's try creating a program that uses SM415 to generate pulse signals that operates with a 100 millisecond cycle and then switch M0 to on when SM415 rises. Set SM400, which is normally on, as contact point A and use the MOV command to store 100 in SD415. The created program can be displayed in waveform and its operation can be checked with GX LogViewer. Just select Tool on the menu bar and then select Real-Time Monitor function to launch GX LogViewer. On GX Works3, click Start Simulation on the menu. On GX LogViewer, select Online on the menu bar and then select Real-Time Monitor. Select the equipment and the connection destination. Then select our CPU simulator, GX Simulator 3, and click OK. Now, input SM415 and M0 for the device items and click Monitor Start. The status of the set device will be shown in waveform. Then, stop the waveform. Let's check whether the pulse cycle is 100 milliseconds long. Select Graph View on the menu bar and select Multiple Cursor. On the left side, next to the rising M0, place a blue cursor, and on the right, place a red cursor. As you can see, although we've intended to generate a pulse signal with a 100 millisecond cycle, the cycle turns out to be 200 milliseconds long. Let's fix the program so that it takes 100 milliseconds for M0 to switch to on. Try adding a falling signal in parallel with the rising signal of SM415. Then, check it like how we just did. Since M0 was also switched to on when the pulse signal fell, a signal with a 100 millisecond cycle could be generated. Now, let's see how to change the SM415 cycle itself. By changing the value to be sent to SD415 in the previous program to 50, SM415 will operate with a 100 millisecond clock, so it's possible to switch M0 to on in 100 milliseconds, even if there's only rising SM415. Timer relays can also operate in the same way as the system clock. A timer relay is a device that switches to on after the set value of the output command has been clocked. The timer constant of timer relays varies depending on the output command used. Next, we'll introduce you a program using T0 to switch M1 to on in 100 milliseconds. Set SM400, which is normally on, as contact point A and T0 as contact point B. Use OUTH command, which means 10 millisecond timer, to output T0 for the set value 10. Then, output M1 when T0 of contact point A is switched to on. So, when checking the cycle with GX LogViewer, you can see that it takes 100 milliseconds for M1 to switch to on. And that's all for the instruction on how to generate fixed cycle signal using the system clocks and timer relays. Now you can create programs suitable for your own application. For more details of the functions and settings, please check the related manuals and Mitsubishi Electric FA Global website. Using this video as a reference, you can generate fixed cycle signals as you want. And after you've become skillful at combining several fixed cycle signals, you can also generate even more complex signals. Don't hesitate to try it for evaluating programs and equipment.